Good afternoon. It is my great honor and privilege as the NAE Chair to welcome all of you to the 2020 National Academy of Engineering annual meeting. It is most unfortunate that we must conduct this meeting in a virtual form, but the realities of the COVID-19 pandemic must be accommodated. We will miss the informal dialogues with colleagues and a most meaningful induction ceremony for new members. But we will be able to benefit from an agenda well suited to our current situation. I trust that you will find that the leadership and staff of the NAE have developed a program that addresses many of the challenges posed by the pandemic to the engineering community. I, for one, am looking forward to hearing what our distinguished speakers have to say. This is truly a challenging time in our nation's history. Even before the emergence of the pandemic, we were participating in what is arguably the most significant societal transformation since the Industrial Revolution 2 centuries ago. The digital transformation has not only changed the ways we communicate, but has challenged the nature of work, of leisure, healthcare, politics, and even the relationships between nations. The COVID-19 pandemic has accelerated that transformation and added elements that challenge previously accepted beliefs. Supply chains are being reevaluated as the pandemic's impact compromises the integrity and assurance of critical sources of supply. We are finding both our electronic and physical infrastructure wanting as the role of cities adapts to changing forms and locations of both work and residences. And we are finding our educational systems, from elementary schools to research universities, challenged in concept and processes. Perhaps most significantly, these changes have created a new schism in society between those who are able to conduct their business from the comfort and safety of their homes, wherever they may be, and those who must take on many risks and challenges. The risk of losing one's job or business, the challenge posed by limited options for childcare, and of course, the risk of contracting the virus. This transformation poses a great challenge to our federal, state, and local governments. Few politicians have any formal training in science, engineering, or medicine, but are being asked to make profound decisions based on what are often highly technical considerations. We often hear the protestations that they will follow the science, but that is not easily done. The science is rarely clear and evolving rapidly. It often requires expert interpretation and evaluation, and it must be put into context. Furthermore, it is often the application of science, the engineering of systems and solutions, that represents the crucial public policy considerations. The National Academies have played a critical role as advisors to the nation ever since the establishment of the National Academy of Sciences in 1863. The academies have been relied upon to provide independent, objective, and nonpartisan advice with the highest standards of scientific and technical quality and integrity. To do so, the academies call on the nation's preeminent experts in science, engineering, and medicine. In this process, the often critically needed engineering perspective has been and will continue to be a major demand function for the NAE. I would like to take this opportunity to thank those of you who have served on National Research Council committees, boards, or NAE programs, and ask that you continue to do so, perhaps at even greater levels of involvement. For those of you who have not done so, I will encourage you to participate. I believe that you will find this form of service to be both intellectually challenging and most satisfying. There is one other aspect of this advisory function that the NAE performs that must be addressed. While study committee members serve pro bono, they are reimbursed for their expenses, which can be considerable, particularly when travel is required. Furthermore, staff support is necessary to guide the study according to the exacting NRC processes that ensure independence, objectivity, and substantiation of all study results. Unfortunately, while many government leaders understand and value the advice from Academy's expert committees, it is increasingly evident that there are a number of issues for which independent, objective, and nonpartisan advice would materially aid in the development of public policy, but that are not requested or funded. Arguably, the simplest way to address this dilemma is for the NAE to take the initiative and self-fund programs and consensus studies to address critical national issues. To do so requires discretionary funding, and this funding must come from donations. We are fortunate that a few significant donations in the past few months will enable us to proceed in this direction in a limited manner, but more are needed. Again, if you have donated previously, I will encourage you to continue to do so and to consider increasing your level of support. And if you have not done so in the past, I will ask you to reconsider your charitable donations and put the NAE fund at the top of your list. Now it is my pleasure to introduce John Anderson, the distinguished president of the NAE, to deliver his address.
Thank you, Don. Welcome to the National Academy of Engineering 2020 annual meeting. As president of the NAE, it is my honor to address this very distinguished gathering and celebrate the introduction of our new members, the class of 2020. Because of the COVID-19 pandemic, our annual meeting this year is being held in virtual mode. So this is an experiment for us. I want to thank our staff for their hard work in adjusting to the current conditions to make this a memorable meeting. I'll begin with some background about the NAE and its sister academies. President Abraham Lincoln signed a congressional charter that created the National Academy of Sciences in 1863 because he saw an urgent need for the government to have a source of independent scientific advice. The National Academy of Engineering expanded that role in 1964 with its creation as a sister organization to the NAS. And in 1970, the Institute of Medicine, which recently became the National Academy of Medicine, was established. Two primary reasons for establishing the NAE were, one, to recognize the profession of engineering and its importance to society, and two, to identify world-class experts in engineering to advise the government and public on technical matters. The first class of NAE members in 1964 had 25, 56% from the business sector, 36% from universities, and 8% from national laboratories. The National Research Council was formed in 1916 to bring into cooperation government, educational, industrial, and other research organizations to advance science, aid the development of American industries, strengthen the national defense, and promote national security and welfare. The NRC is the operating arm of the overall organization called the National Academies of Sciences, Engineering, and Medicine, or NASEM. Along with that background, I should point out that the academies are not part of the government, and this is by design. Our work is independent, There is no federal line item for us, nor any congressional appropriation, as many may think. The vital work of the NAE and the institution as a whole depends on sponsors, donors, and volunteers. And I will be calling on all our members and friends to help with financial support of the National Academy of Engineering. We need your support to advance the mission of the NAE. The mission of the National Academy of Engineering is to advance the well-being of the nation by promoting a vibrant engineering profession and by marshaling the expertise and insights of eminent engineers to provide independent advice to the federal government and society on matters involving engineering and technology. This mission is accomplished through the work of the NAE members in studies and activities of both the NRC and the NAE Program Office. To support our mission, we have reorganized the NAE Program Office consistent with what I call the 4 I's. Identify and inform the frontiers of engineering theory, practice, and policy. Increase engineering talent through a strong commitment to diversity and inclusion. Instill a culture of ethical and environmental responsibility in engineering. And improve capabilities and competencies for complex systems engineering. As examples, I offer a few NAE initiatives that support these objectives. The publicized instances of police injustice inflicted on black men and women over the past several months remind us of the continuous injustice suffered by over centuries by minority populations in our country. In parallel with racial injustice is a stagnation or even decline in the percentage of minority students receiving degrees in engineering, thereby resulting in lost talent to the engineering profession. Several of our members wrote me and asked, what can we do about this situation? In response, we created a committee on racial justice and equity, which is tasked to recommend actions that the engineering community and the NAE should take to further racial justice and equity for all our citizens. This committee aligns with our mission. To serve society, we must be aware of problems in society and potential consequences of our work. I believe engineering has much to offer in improving justice and equity for all our citizens, and the dedicated members of this committee will produce recommendations for action by the NAE. The COVID-19 pandemic has presented the world with its greatest challenge this century, and engineers, along with scientists and medical professionals, have worked together in the public and private sectors to address it. The contributions from engineering are apparent and numerous. To name a few: the internet, Wi-Fi, platforms like Zoom, computers, and microelectronics, which allow people to telework and communicate. Production of medical devices, diagnostics, and safety clothing. Development of robust supply chains of materials and chemical precursors. And the need to scale up the production and distribution of vaccines and therapeutics. One very timely and dynamic initiative of the National Academy of Engineering in partnership with universities and others is the call to action against COVID-19. Launched in April, it combines the imagination and talents of university engineering students in our Grand Challenges program, mid-career professionals who have participated in our Frontiers of Engineering program, and seasoned engineering veterans who are NAE members. It is truly intergenerational. It works like this. Students and faculty members form teams and submit ideas to a technical review committee, which is composed of alumni from our Frontiers of Engineering program. The ideas judged to be most promising are forwarded to an NSF program called I-Corps that works with the inventors to develop pitches to attract investments toward commercialization. The top teams then make their pitches to the expert review committee, which is composed of NAE members. The pitch sessions are fun to watch and inspiring. A few good ideas are being pursued as potential startup companies. These ideas may become tangible actions to address the COVID-19 pandemic, but I think the greatest product of this initiative might be the intergenerational learning occurring in both directions between young and experienced engineers. The enthusiasm among all participants is contagious. I encourage you to watch the recordings of the pitch sessions. They are posted on the NAE website, which is on the slide. Another new initiative is NAE Perspectives, a series of short-form commentaries accessible to a wide range of audiences and published on the NAE website. The goal is to foster member and public engagement in technical topics of current relevance and interest to society. These commentaries may be supplemented with video, social media, and webinar dissemination. The first two perspectives were authored by NAE members of the class of 2020. Charlie Bolden, former NASA administrator and astronaut, and Gwynne Shotwell, President and COO of SpaceX. We are excited about this new series, which will highlight how engineers are contributing to the progress in a variety of fields. In order to strengthen the NAE program office, we recently hired Dr. David Butler. David has been with the National Academies for 24 years, and his experience will help advance programs such as the NAE's Cultural, Ethical, Social, and Environmental Responsibility Initiative, as well as various National Academies studies related to engineering and environmental health topics. David is the J. Herbert Holloman Scholar. Dr. Holloman was one of the founding members of the NAE. This position was made possible by the Holloman Memorial Committee, chaired by David Roos, on the occasion of the NAE's 25th anniversary. I now turn to the truly important part of the program, recognition of the NAE class of 2020. Consider this a brief introduction of our new members. We will repeat this ceremony in person at the annual meeting in 2021, so that every member of the class of 2020 will have the opportunity to be properly introduced and walk across the stage of this auditorium to sign the membership rolls. The first class of NAE members in 1964 numbered 25. They were all white males. The class of 2020 looks a bit different. Among this year's 86 newly elected members, 31% are women and 9% are from underrepresented minority groups. I congratulate the NAE members who served on our election committees and brought about this result. This year's election brings the total to 2,271 members. The class of 2020 also includes 18 international members. They are from 13 countries, and one of them is the first member elected from his country. There are 5 women elected this year as international members, significantly more than the average of 2 women elected per year over the previous 4 years. This year's election brings the total to 279 international members. A major goal of the NAE strategic plan adopted in 2015 was to increase the diversity of our membership in terms of gender, racial, and ethnic representation. Another goal was to increase the number of nominations and elected members from the business sector. The driving force behind these goals was to improve the talent of the NAE membership, and the strategy was to cast a wider net for nominations and search hard for outstanding candidates to nominate for membership. Thanks to the hard work and commitment by our home secretaries, our section search committees, and our election committees, we have made good strides over the past 5 years, as shown on the slide. Over this time period, 52% of our new members are from the business sector, 26% are women, and 8% are from underrepresented minorities. While progress in diversification of our membership has not been fast, the data indicate we are moving in the right direction. Of course, it is imperative that we maintain our commitment to the diversity of the NAE, but our programs must also promote recruitment of women and underrepresented minorities into the engineering education and careers. We need the talent if engineering profession is to continue to flourish. One thing that has not changed over the years, election of NAE members is based on demonstrated achievement and impact of work. The selectivity is very high. Only one of every 6 nominees was elected this year, and all nominees are highly accomplished. Now, having said this, I want to make one point to the families of today's inductees. As accomplished as they are, the new members are still expected to take out the trash, clear the dinner table, and perform other chores they had before election to the NAE. Election does not relieve them of their domestic engineering responsibilities. On a more serious note, I want to emphasize the expectation of service and volunteerism for NAE members. Keep in mind that engineer is a verb implying action. It is a great honor to be elected to the NAE, but like a university commencement, it is just the beginning. We will be calling on you to help fulfill our mission of service to the nation. I look forward to working with you as we work together toward betterment of the country, the world, and this organization. For that, I thank you in advance. I would like to take this opportunity to thank all the NAE staff who make our organization work so well. It is a wonderful group of individuals, and they make good things happen. I would also like to acknowledge the great group of officers and counselors who govern the NAE. These individuals are elected by members to serve the organization, and they do it very effectively. I congratulate the class of 2020 and now introduce Dr. Al Romig, NAE member and executive officer, who will introduce the members and international members of the NAE class of 2020. Al?
Thank you, John. And as John said, my name is Al Romick, and I am the current NAE Executive Officer. We are extremely proud of our new members, and we're also proud of our long-serving members. We're excited to recognize them in this virtual meeting. The following individuals are celebrating a significant membership anniversary, and we'll show you some photos along the way. The class of 1970, celebrating 50 years, Arthur Bryson, Ross McDonald, and William Perry. 7 members from the class of 1975, celebrating 45 years. 18 members from the class of 1980, celebrating 40 years. 23 members from the class of 1985, celebrating 35 years. 39 members from the class of 1990, celebrating 30 years. And 56 members from the class of 1995, celebrating 25 years. We'd like to thank and congratulate all of our anniversary members for their years of service. The names of all of our anniversary members are also available in our online directory. As John and Don both said, although we are unable to sit together in the great auditorium at the National Academies this year, we are grateful for this opportunity to celebrate and acknowledge excellence in engineering. We are optimistic that current advances in engineering will foster a brighter future for us all. Today, we are celebrating the marvelous contributions that the engineers in this year's class have made in research, innovation, manufacturing, education, the creation of novel technologies, and in designing solutions to real-world problems. I think you know how competitive this process is. John alluded to that. From personal experience, as former chair of the Committee on Membership, I know how talented these classes are. And as executive officer, I had the opportunity to review this year's class, and you are all as distinguished as ever. Arthur C. Clarke, an international member of the NAE, now deceased, and the author of 2001: A Space Odyssey, said that any sufficiently advanced technology is indistinguishable from magic. We take this moment to acknowledge some of the magic of engineering. Engineering is a marvelously creative enterprise, and the citations reflect that creativity. Engineering improves the human condition, and as you have heard earlier today, and that is a message that we are consistently trying to convey to the public, young and old. John cited our history going back to the National Academy of Sciences in 1863 as an organization that is meant to use the talents of the nation's preeminent scientists, engineers, and physicians. In light of the global challenges we currently face, now more than ever, it is important that the National Academy of Engineering continue to engage in this endeavor. Now to the introduction of our new members and international members. For all of you who are joining today, you know we make great efforts to introduce people by properly pronouncing their names. And I will tell you that with the help of my assistant, between talking to you, listening to voicemail, talking with your assistants or your colleagues, and finally consulting Mr. Google, I'm going to try my very best, despite my American accent. What I'm going to do is read the name, the affiliation, and the election citation, first for the new members, and then for the new international members. Now, to the introduction of the class of 2020. Lilia Ann Abram, President and Chief Executive Officer, Peer Consultants, PC, for leadership in providing technology-driven sustainable housing and environmental engineering solutions in the United States and South Africa. Eleanor J. Allen, Chief Executive Officer, Water for People, for leadership and advocacy in making clean water and sanitation systems accessible to people around the world. David J. Allstott, Professor, Electrical Engineering and Computer Science, Oregon State University, for research and commercialization of mixed-mode integrated circuits and systems. Robert O. Ambrose, Division Chief, Software, Robotics, and Simulation Division, NASA Johnson Space Center, for advances in dexterous space robotics and leadership in human-robotic teaming in space operations. Saeed D. Barbat, Executive Technical Leader, Safety, Policy, and Vehicle Analytical Tools, Ford Motor Company, for leadership in automotive safety and contributions to the science of crashworthiness, occupant protection, and biomechanics. Peter J. Basser, NIH Senior Investigator, Section on Quantitative Imaging and Tissue Science, National Institutes of Health, National Institute of Child Health and Human Development, for development of diffusion tensor MRI and streamline tractography, transforming the characterization of brain disorders and visualization of nerve fiber pathways. Barbara A. Beacons, Research Hydrologist, U.S. Geological Survey, for contributions to characterizing subsurface microbial populations related to contaminant degradation. Stacy F. Bent, Jagdeep and Roshni Singh, Professor of Engineering, Department of Chemical Engineering, Stanford University, for contributions to materials surface chemistry and its application across technology platforms from energy to electronics. Thomas A. Burson, Advisory Board member, Salesforce.com Incorporated, for contributions to cybersecurity in the commercial and intelligence communities. Stephen Biller, Vice President, Watson IoT, International Business Machines Corporation, for leadership and advancement of manufacturing technologies and innovations based on the Internet of Things and digital data. Charlie Bolden, founder and CEO Emeritus, the Charles F. Bolden Group, LLC, for leadership and development of U.S. human spaceflight and space operations programs, and for revitalizing fundamental aeronautics research. Allison K. Brown, President and CEO, Navsys Corporation, for contributions to research and development of precision navigation and timing technologies. Marilyn A. Brown, Chair, School of Public Policy, Georgia Institute of Technology, for bridging engineering, social and behavioral sciences, and policy studies to achieve cleaner electric energy. Graham V. Candler, McKnight Presidential Chair, Aerospace Engineering and Mechanics, University of Minnesota, for development and validation of computational models for high-fidelity simulation of supersonic and hypersonic interactions. Reginald DesRoches, Howard Hughes Provost, George R. Brown School of Engineering, Rice University, for research and design of resilient infrastructure systems to mitigate damage from natural disasters and other extreme conditions. Joel S. Emmer, Senior Distinguished Research Scientist, NVIDIA, for quantitative analysis of computer architecture and its application to architectural innovation in commercial microprocessors. Horatio D. Espinoza, James and Nancy Farley Professor of Manufacturing and Entrepreneurship, Mechanical Engineering Department, Northwestern University, for contributions bridging nanoscale experimentation and atomistic simulations. John C.C. Fan, Founder, Chairman, CEO, and President, Kopin Corporation, for innovation and entrepreneurship in electronic materials and devices for displays. Margaret M. Fall, Vice President, Drug Product Technologies, Amgen, for technical leadership in the development of marketed medicines and leadership in enabling technologies, pharmaceutical standards, green chemistry, and sustainability. Carl N. Fleming, President, KNF Consulting Services, LLC, for contributions to probabilistic risk assessment methods and their application to enhance the safety of nuclear power facilities. Jean A. France, co-founder and former Chief Technical Officer, Octavo Systems, LLC, for leadership in the development and commercialization of digital signal microprocessors. Paul L. Friedman, Chief Executive Officer, Limnotech, for development and application of science-based computer models for water body and watershed assessment, remediation, and management. Rajiv Gautam, President and Chief Executive Officer, Honeywell, for business and technical leadership in the oil, gas, and petrochemicals industry. Eric Gebhardt, Executive Vice President and Chief Technology Officer, Wabtec Corporation, for development and utilization of advanced electric generation technologies, including gas and wind turbines. Thomas R. Gelorenzi, Senior Fellow, L3 Harris, for innovation and entrepreneurship in civilian and military communications networks and systems. Robert B. Gilbert, Professor and Department Chair, Department of Civil, Architectural, and Environmental Engineering, the University of Texas at Austin, for advancing the use of reliability analyses, risk assessment, and risk-based decision-making for complex engineering projects. Kenneth E. Goodson, Davies Family Provostial Professor and Senior Associate Dean, School of Engineering, Stanford University, for developments in microprocessor thermal management and nanoscale heat conduction. Kenneth C. Hall, Julian Francis Abley Professor, Department of Mechanical Engineering and Materials Science, Duke University, for development of unsteady aerodynamic and aeromechanics theories and analysis for internal and external aerodynamic flows. Vicki L. Hansen, Executive Director and Chief Executive Officer, Association for Computing Machinery, for contributions to the design of accessible systems and for leadership in the computer science and engineering community. LaTanya M. Harris, Scientific Director, CMC Leader, Janssen R&D Portfolio Management, Janssen Pharmaceutical Companies, for leadership in biomanufacturing of a breakthrough immunotherapy biotherapeutic and for outreach activities in STEM education. Susan J. Helms, Principal and Owner, Orbital Visions, LLC, for accomplishments in civil and military space programs. Susan V. Herring, President, Aerosol Dynamics Incorporated, for advances and commercialization in aerosol measurements and instrumentation. Susan S. Hubbard, Associate Laboratory Director and Senior Scientist, Earth and Environmental Sciences, Lawrence Berkeley National Laboratory, for contributions to hydrogeophysics and biogeophysics and the geophysics of permafrost. Omar Ishrak, Chairman and Chief Executive Officer, Medtronic Incorporated, for contributions to diagnostic ultrasound and for leadership in medical technology innovation and globalization. Keoki Jackson, Chief Engineer and Vice President for Engineering and Program Operations, Corporate Engineering, Technology and Operations, Lockheed Martin Corporation, for developing human and technological aerospace capabilities for national security and for promoting global technology cooperation. Merjan Yankovic, Senior Technical Leader, Ford Research and Advanced Engineering, Ford Motor Company, for contributions to nonlinear control theory and automotive technology. Sally A. Keller, Distinguished Professor of Biocomplexity, University of Virginia Biocomplexity Institute and Initiative, for development and application of engineering and statistical techniques in support of national security and industry. Ioannis G. Kevrakidis, Bloomberg Distinguished Professor, Johns Hopkins University, for research on multi-scale mathematical modeling and scientific computation for complex nonlinear reaction and transport processes. Ron Klemenczyk, Chairman and Chief Executive Officer, Magnuson Klemenczyk Associates Incorporated, for innovation in the design of high-rise buildings worldwide and for research and design guidelines to advance structural engineering practices. Tammy G. Golda, Distinguished Member of Technical Staff, Informatics and Systems Assessments, Sandia National Laboratories, for contributions to the design of scientific software, including tensor decompositions and multilinear algebra. Julia A. Cornfield, Elizabeth W. Gillian Professor of Chemical Engineering, Division of Chemistry and Chemical Engineering, California Institute of Technology, for developing mega supermolecules for anti-misting fuel additives and light-adjustable intraocular lenses to improve cataract surgery outcomes. Paul E. Krajewski, Director, Vehicle Systems Laboratory, General Motors R&D Center, for development and implementation of lightweight automotive materials. Stephen L. Kramer, Professor, University of Washington, for contributions to geotechnical earthquake engineering, including liquefaction, seismic stability, and seismic site response. Thomas R. Kerfus, Chief Manufacturing Officer, Manufacturing Demonstration Facility, Oak Ridge National Laboratory, for development and implementation of innovative digital manufacturing technologies and systems architecture. James F. Carosa, Distinguished Professor, College of Information and Computer Science, University of Massachusetts Amherst, for contributions to the design and analysis of network protocols for multimedia communication. Sarah Kurtz, Professor, University of California, Merced, for contributions to the development of gallium indium phosphide and gallium arsenide photovoltaic cells and leadership in solar cell reliability and quality. Mark G. Lobby, Senior Vice President and Chief Engineer, North American Electric Reliability Corporation, for the development and application of techniques for electric grid reliability analysis. Fei Li, Sequoia Capital Professor, Operations, Information, and Technology, Co-Director, Stanford Institute for Human-Centered Artificial Intelligence, Stanford University, for contributions in building large knowledge bases for machine learning and visual understanding. Eugene Litvinov. Unfortunately, Dr. Litvinov passed away between his election to the Academy and today's introduction of new members. Dr. Litvinov was the Chief Technologist of Business Architecture and Technology at ISO New England. He was elected for the development of optimization mathematics for new electricity markets and innovative applications for electric grid control, visualization, and planning. Chen-Ching Liu, American Electric Power Professor, Director, Power and Energy Center, Electrical and Computer Engineering, Virginia Tech, for contributions to computational methods for power system restoration and cybersecurity. Susan S. Margulies, Wallace H. Coulter Professor and Department Chair, Biomedical Engineering, Georgia Institute of Technology and Emory University, for elaborating the traumatic injury thresholds of brain and lung in terms of structure-function mechanisms. Thomas L. Marzetta, Electrical and Computer Engineering, Tandon School of Engineering, New York University, for contributions to massive multiple input, multiple output antenna arrays in wireless communications. Paul F. McKenzie, Chief Operating Officer, CSL Behring, for delivering breakthrough medicines, modernizing process development and manufacturing, and integrating modern engineering concepts in pharmaceutical industries. Muriel Medard, Cecil H. Green Professor, Electrical Engineering and Computer Science, Massachusetts Institute of Technology, for contributions to the theory and practice of network coding. Lehio H. Mejia, Senior Principal, Geosyntec Consultants, for the evaluation, design, and construction of embankment dams and foundation systems and contributions to geotechnical earthquake engineering. Russell D. Meller, Vice President, Solution Design and R&D, Fortna Incorporated, for contributions to large-scale distribution center design and operation. James Adichie Momo, Chairman and Chief Executive Officer, Nigerian Electricity Regulatory Commission, for the development of electric grid optimization techniques and implementation of advanced technology and policy for emerging electric grids in Africa. Paulo J. Monteiro, Professor, Civil and Environmental Engineering, University of California, Berkeley, for contributions to the science and nanotechnology of concrete for sustainable construction and durable structures. Jayathi Y. Murthy, Ronald and Valerie Sugar Dean and Distinguished Professor, School of Engineering and Applied Science, University of California, Los Angeles, for the development of unstructured solution adaptive finite volume methods for heat, mass, and momentum transport. Laura E. Nicholson, Professor of Anesthesiology and Biomedical Engineering, Yale University, for cardiovascular tissue engineering, lung regeneration, and biomedical imaging. Jorge Nocedal, Walter P. Murphy Professor, Northwestern University, for contributions to the theory, design, and implementation of optimization algorithms and machine learning software. Ellen Ochoa, Center Director, Astronaut, NASA Johnson Space Center, retired, for service as an astronaut, a technical leader in government, and an optical scientist engineer. Sarah N. Ortwine, former President, XTO Energy, ExxonMobil Corporation, retired, for engineering leadership in the upstream sector of the oil and gas industry. Per F. Peterson, Floyd Distinguished Professor of Engineering, Department of Nuclear Engineering, University of California, Berkeley, for experimental and analytical research contributions for the design and development of passive safety systems for advanced nuclear reactors. Frank F. Roberto, Senior Manager, Processing Technology and Innovation, Technical Services Processing and Metallurgy, Molizanov Technical Facility, Newmont Corporation, for advancing biotechnical applications for environmentally responsible mine production. Ann K. Roby, Executive Vice President, Linde PLC, for developments in oxidation processes and leadership in technological developments, safety, and business growth in global industrial gas companies. Reza Rofagaran, co-CEO, CTO, and co-founder, Movandi Corporation, for the development of radio system on a chip technology for wireless networking. Mark E. Russell, Corporate Vice President, Engineering, Technology, and Mission Assurance, Raytheon Technologies, for leadership in developing radar systems for enhanced national security and safety. Amarpreet S. Sahani, Chairman and CEO, Instilia Incorporated, for development of innovative medical devices that have impacted millions of patients. Alexander Shapiro, A. Russell Chandler III Chair and Professor, School of Industrial and Systems Engineering, Georgia Institute of Technology, for contributions to the theory, computation, and application of stochastic programming. Peter W. Shore, Morse Professor of Applied Mathematics, Department of Mathematics, Massachusetts Institute of Technology, for pioneering contributions to quantum computation. Gwynne E. Shotwell, President and Chief Operating Officer, SpaceX, for bringing affordable, commercially competitive space transportation to NASA and the U.S. national security space launch. Nancy R. Satos, Swanlund Endowed Chair and Department Head, Materials Science and Engineering, University of Illinois at Urbana-Champaign, for contributions to the design and applications of self-healing and multifunctional materials. Michael A. Sutton, Carolina Distinguished Professor Emeritus, Mechanical Engineering, College of Engineering and Computing, University of South Carolina, for creation of digital image correlation-based measurement technology and its dissemination through commercialization and applications in industry. Maria C. Tamargo, Professor, Physical Chemistry and Inorganic Chemistry, City College of New York, for forging the way toward an inclusive science and engineering research community and for contributions to molecular beam epitaxy of semiconductor materials. Russell H. Taylor, John C. Malone Professor, Department of Computer Science, Johns Hopkins University, for contributions to the development of medical robotics and computer-integrated systems. Mark E. Thompson, Professor of Chemistry and Material Science, University of Southern California, for development of highly efficient electrophosphorescent materials for organic light-emitting devices used in displays and lighting worldwide. Rudolph M. Trump, Research Staff Member, IBM Research Division, IBM T.J. Watson Research Center, for contributions to development and commercialization of nanoscale characterization methods and their application in material science. Leon Sang, Professor, Electrical Engineering and Computer Science, University of Michigan, for contributions in wave scattering and microwave remote sensing theories for satellite missions. Carrie J. Fahala, Jenkins Professor of Information Science and Technology, Applied Physics and Material Science, California Institute of Technology, for research and application of nonlinear optical microresonators to the miniaturization of precision time and frequency systems. Richard A. Vaya, Senior Technologist, Emergent Material Systems and Manufacturing Directorate, Air Force Research Laboratory, for aerospace applications of polymeric nanomaterials and for technical leadership in materials for national defense applications. Stephen H. Walker, Vice President and Chief Technology Officer, Corporate Engineering, Technology, and Operations, Lockheed Martin Corporation, for leadership of national security R&D at the Defense Advanced Research Project Agency and the U.S. Air Force. Charles W. Wampler II, Senior Technical Fellow, Chemical and Material Systems Laboratory, General Motors Global R&D, for leadership in robotic systems in manufacturing, mathematical methods for robot motion, and machine design and traction battery modeling. Kenneth E. Washington, Chief Technology Officer, Ford Motor Company, for leadership in nuclear safety, information systems and high-performance computing, space research, and automotive technologies. Dick K. Yu, Philip J. Solance Professor of Engineering and Professor of Mechanical and Ocean Engineering, Massachusetts Institute of Technology, for contributions to ocean engineering and innovation of open courseware to make higher education freely available worldwide. G. John, Chairman and Chief Scientist, Giacomo, LLC, for advances in earthquake seismology, geophysical imaging, and medical technology. Now for the introduction of the Class of 2020 international members. Edward Artz, Scientific Director and CEO, Leibniz Institute for New Materials, Professor for New Materials, Saarland University, for research on mechanical properties and development of bio-inspired functional surfaces for medical adhesives and novel gripping systems. Gunther Bluschel, Professor of Hydrology and Water Resources, Institute of Hydraulic Engineering and Water Resources, Vienna University of Technology, for international leadership in the prediction and management of extreme hydrological events. Dae-Jae Jin, Chief Executive Officer, Skylake Investment Company, for innovations and industry leadership in semiconductor technology. Raffaello D'Andrea, Professor, Department of Mechanical and Process Engineering, ETH Zurich Institute for Dynamic Systems and Control, for contributions to the design and implementation of distributed automation systems for commercial applications. Soonhan J. Den, co-founder and chairman, Vimicro Group, Zongjing Microelectronics Company, Limited, for development of the world's first CMOS single-chip web camera and China surveillance video and audio coding national video standard. Igor Emery, Chair Professor of Mechanics, Faculty of Mechanical Engineering, University of Ljubljana, for contributions to the testing and modeling of time-dependent materials and to novel sound and vibration isolation materials. Claudia A. Felser, Director, Solid State Chemistry, Max Planck Institute for Chemical Physics of Solids, for the prediction and discovery of engineered quantum materials ranging from Heusler compounds to topological insulators. Pawan K. Goenka, Managing Director and CEO, Mahindra & Mahindra Limited, for leadership and expansion of Mahindra's automotive business in India and contributions in automotive engine lubrication. Susan T. Harrison, Deputy Vice Chancellor and Professor Chemical Engineering, University of Cape Town, for leadership in biochemical engineering and its application to mining and environmental remediation. Chenupati Jagadish, Distinguished Professor, Research School of Physics, Australian National University, for contributions to nanotechnology for optoelectronic devices. Wolfgang Margit, Chairman of the Board of Directors, Forschungszentrum Jülich GmbH, for contributions to process systems engineering and large-scale computations, and for national leadership in science technology policy and management. Roberto Melli, Research Professor, National Autonomous University of Mexico, for advancing the preservation of historic structures and improving the seismic safety of concrete, masonry, and adobe structures worldwide. Michael V. Sefton, University Professor, Chemical Engineering and Applied Chemistry, University of Toronto, for advances in biomaterials and tissue engineering through cell microencapsulation and leadership of large-scale research initiatives. Abigail J. Sellen, Deputy Director and Principal Researcher, Microsoft Research Cambridge, UK, for contributions that ensure consideration of human capabilities in the design of computer systems. Isam A. Charoff, Professor, Cairo University, for leadership to modernize transportation systems in Egypt and the Middle East through scholarship, advocacy, and public policy. Su Guanning, President Emeritus, Nanyang Technological University, for contributions to regional security and defense and for academic leadership. Viola Vogel, Professor, Department of Health Sciences and Technology, ETH Zurich, for elucidation of how proteins work as nanoscale mechanochemical switches and applications to bioengineering and medicine. Rabab K. Ward, Professor Emeritus, Electrical and Computer Engineering, University of British Columbia, for innovative applications of signal processing to industrial and bioengineering problems. Join us now where you are, and let's celebrate the NAE class of 2020. Congratulations.